Hello classmates. Starting today, let's learn about sludge treatment together. So, let's take a look at the first aspect today, characteristics of sludge. As we all know, there are many sources of sludge. Today, what we will first learn about is sludge from sewage treatment plants. So, in the sewage treatment plant, various stages will produce a lot of sludge. For example, from the grill, from the initial sedimentation tank to the biochemical tank and the secondary sedimentation tank. So, in these processing processes, a large amount of sludge is generated. For different types of sludge, it is necessary for us to classify it. In general, we can classify sludge according to its composition. Of course, we can also classify according to the stages of sludge treatment. Let's take a look at the first one first. If classified according to the composition of sludge, so we will divide the sludge into organic and inorganic sludge. So-called organic sludge refers to sludge containing a large amount of organic matter. Their density is relatively small. Often it floats in the middle of the water or on the surface. The second part is inorganic sludge. Inorganic sludge is mainly composed of inorganic substances. Their density is generally relatively high. The particles are also larger. Usually it sinks to the bottom of the pool. This is the composition of sludge, divided into two types. Second type, it is divided according to the stages of sludge disposal. We divide it into raw sludge, concentrated sludge, dehydrated sludge, digested sludge. It refers to the sludge generated during the biochemical treatment stage. Generally, activated sludge is the main method. Concentrated sludge. After concentration in the concentration tank, produced sludge, their general moisture content will be around 95%. In this case, the sludge is in a paste-like state. At this point, they are also flowing. Dehydrated sludge refers to the dehydration of sludge after processing, so the moisture content of sludge, from 95% to 55% to 80%. The sludge in this situation, generally in a semi-solid or solid state. The fourth type is digested sludge. Digestive sludge refers to the digestion of sludge. So, at this stage, organic components in sludge, basically, it is subjected to anaerobic or aerobic nitrification to some inorganic components. At this point, the density of sludge is relatively high. The particles are also larger. Besides, we will also divide the sludge into this dried sludge. So, dried sludge refers to treatment of sludge after digestion and dehydration. Conduct a natural drying process. Secondly, it is important to understand the treatment of sludge. We also need to be clear some property indicators of sludge. This property indicator, we will learn from the following 5 aspects. 1. Ideographic comma, it is the moisture content of sludge. Secondly, it is the density of sludge. 3. Ideographic comma, it's the volatile matter and ash of sludge. 4. Ideographic comma, it is the digestion performance of sludge. Characteristics of sludge. Let's take a look at the first sludge moisture content first. Everyone knows there is a large amount of water inside the sludge. So, regarding moisture content, it refers to the quality of water contained in sludge, percentage of the ratio to the total mass of sludge, called sludge moisture content. In general, moisture content of sludge in the initial sedimentation tank, between 95% and 97%. Excess activated sludge reaches over 99%. Why do we need to understand the moisture content of sludge? The main reason is that, to facilitate the calculation of sludge concentration in the future, and the calculation of sludge transportation needs. So we understand, the moisture content of sludge must be less than 80%. Only then can they be transported out of the factory. How to remove the moisture from a large amount of sludge? Remove from sludge. We must be clear about the moisture inside the sludge. It mainly consists of capillary water and interstitial water. 4 types of water composition: adsorbed water and internal water. The proportion of interstitial water is about 70%. It refers to the water present between the gaps in the sludge. The second part is capillary water. Capillary water accounts for 20%. It is some moisture outside the sludge particles. The third part is about adsorbed water and internal water. This accounts for 10%. The adsorbed water is due to adsorption, attached to the surface of sludge particles. The internal water is present inside the sludge particles. These two parts of water, it is particularly difficult to remove from the sludge. It's also our future work in sludge dewatering, parts that require special attention. The second characteristic is the density of sludge. So the density of sludge, we usually use relative density to introduce. Quality of wet sludge, equal to the sum of the moisture content of sludge and the mass of dry solids. Relative density of wet sludge, equal to wet sludge, the ratio of its mass to the mass of heavy volume water. Under general circumstances, we believe that sludge with a moisture content above 95%, its density is consistent with the density of water, that is, the density is 1. The third characteristic is the volatile and ash content of sludge. We understand, the sludge is composed of organic and inorganic substances. So, this volatile solid mainly refers to the content of organic matter. Usually, its measurement is feed sludge into in an incinerator with a temperature range of 550 to 600 degrees Celsius. Conduct incineration, so organic matter in the form of volatile matter spill out of the air. The quality of this part is the mass of our volatile solids. We call it volatile matter. Another volatile component refers to the content of inorganic substances. Usually, sludge is injected into in a drying oven between 550 and 600 degrees Celsius. Perform drying, so determine its residue, to determine the mass of this ash content. The fourth is the digestion performance of sludge. So digestion performance is usually used to represent sludge, the amount of organic matter that can be digested and degraded in. One of its calculation formulas is that ρ equals 1 minus PV2. PS1 is 100% higher than PV1 and PS2 multiplied by, using a formula to calculate. In here, the p-values represent mature sludge, respectively, or the inorganic content of raw sludge. The fifth characteristic is the dewatering performance of sludge. Under general circumstances, sludge dewatering performance, we use sludge-specific resistance, or capillary water absorption time. So here are two figures. Figure 1 shows a measuring device for specific resistance of sludge. Figure 2 is a measuring instrument for capillary water absorption time. The so-called sludge-specific resistance refers to the sludge under a certain pressure, resistance per unit filtration area. So it's obvious that the higher the resistance value, the poorer the dewatering performance of our sludge. Capillary water absorption time refers to the contact between sludge and filter paper. So we need to expand 1 centimeter above the particles. Time consumed. Obviously, the longer the time consumed, this means that the longer the capillary water absorption time, the higher this value, the poorer our dehydration performance. So the above are several performance characteristics of sludge. Understand them. For our next step in sludge disposal, it has a great guiding effect. Okay. The content of today's section, that's all we need to talk about. Thank you all.